students. In this video, we're going to be going through the answer key for the Chapter 5 review number 2. Again, that's review number 2. Please make sure you've tried all of these questions before you watch this video. You can then use this video to correct your work. If you have any questions at the end of the video, please let me know. Remember, this review looks identical to your test, and in fact, your test will actually be a little bit easier. So all the questions on this will be on your test, but the ones on your test will use easier numbers. Question 1 asks us to identify the terms, coefficients, and constants of this expression, 12x plus 2 plus 17. So first, the terms, those are the pieces that are separated by addition or subtraction symbols. So the first term I see is 12x, and then the next term I see that's separated with addition symbols is 2, and then the last term I see is 17. So really all I did was I took my expression and I rewrote it, replacing the addition symbols with commas. I turned it into a list of terms, 12x, 2, and 17. Coefficients are numbers that are in front of the variable. I only see one variable here, that is x. The number in front of it is 12, so the only coefficient is 12. And finally, constants are terms that have no variable attached. It's a term that is just a number, no variable. I see two terms that are just numbers with no variable. They're 2 and 17. Question 2 asks us to write the expression 4 times r times times x to rewrite that using exponents. So we use exponents when we have repeated multiplication. So it looks like I have 2 r's and 2 x's, so two sets of repeated multiplication. So the 2 r's, that can be rewritten as r squared, r to the second power, 2 r's. And the 2 x's can be rewritten as x to the second power, 2 x's. These are multiplied together. And then don't forget that 4. It doesn't just go away, it just happens to have no other 4's. So I end up with 4 times r squared times x squared. And then I can get rid of those multiplication symbols if I would like, because if they're all touching, it automatically means they're multiplied. 4r squared x squared. 4 times 2 r's times 2 x's. Question 3 says evaluate 4 plus 3x when x equals 8. So first we are going to replace x with 8. Make sure you put it in parentheses so that this says 3 times 8, not 38. Now I need to use GEMDAS to evaluate this. Multiplication comes before addition. So multiply 3 times 8 is 24. Add 4 plus 24 is 28. Question 4 says write the phrase as an expression. The phrase is 13 subtracted from a number x. So look, I'm basically rewriting this using numbers, variables, and operations. So I see the number 13, the variable x, and then the words subtracted from are connecting them. So I need to decide what operation that means. Subtracted from does mean subtraction, but it doesn't actually mean 13 minus x. It's one of those phrases that means to take the first number away from 13 subtracted from x, to take that away from the x, to write x minus 13 instead. So subtracted from is one of those ones where we switch the order. 13 subtracted from a number x can be written as x minus 13. Next, question 5 says write the phrase as an expression, a number t cubed. So I just have one variable here, t, and then the word cubed is describing what to do to this t. Cubed is a word we learned back in chapter 1. We learned about exponents. We would say cubed when we had something with an exponent of 3. So t cubed means t to the third power, t with an exponent of 3. Question 6 says it costs $6 to bowl a game. And then it also costs $4 for shoe rental. They want us to write an expression that represents the total cost in dollars of G games. G equals number of games. This is just saying, hey, let's write an expression where G represents the number of games that will tell us the cost to play that number of games. So first, let's start with the $6 per game. If I pay $6 per game, what am I doing with 6 and then the number of games, G? Well, if I play one game, that's $6. If I play 2 games, that's $12. If I play 3 games, that's $18. So it sounds like I'm multiplying $6 by the number of games. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. So I'm multiplying 6 and G. $6 times the unknown number of games, 6 times G. I also have to rent shoes though, and I only need to rent those shoes once. It's always just going to be $4 for shoes. So to get the total of these two parts, I'm going to add them together. $6 per game, 6 times number of games, plus $4 for shoes. And if I would like, I can remove the multiplication symbol and just write 6G plus 4. $6 per game plus $4 for shoes. Question 7 says to simplify this expression using the distributive property. The expression is 6 multiplied by the group, 7x minus 1. So the 6 is touching the parenthesis. That means that the 6 is multiplied by the whole group. So I need to multiply 6 by both things in the group, by the 7x and by the 1. 6 times 7x and 6 times 1. 6 times 7x, well, 6 times 7 is 42. So 6 times 7x is 42x. And then 6 times 1 is 6. So I end up with 42x minus 6. Question 8 asks us to simplify this expression, 2z plus 7 plus 6z plus 3, by combining like terms. So there's no distributive property, no number multiplied by a group, but we are going to combine like terms. So first, let's identify the like terms, the terms that have the same variable or have none at all. So I have 2z that has a z on it, and then also a 6z. They both have a z, they have the same variable, they are like terms, so I'm putting the same shape around both. I also have a 7, which is just a constant, a number by itself, and another constant, 3. So those are also alike. I'll put the same shape around those. So now I'm going to go ahead and rearrange my expression to get the like terms next to each other. I'm going to do that by just swapping the middle two to end up with 2z plus 6z plus 7 plus 3. So the 2z and 6z are next to each other, 7 and 3 are next to each other. Notice that when I moved each piece, when I moved 6z, I still kept the same symbol in front. It still said plus 6z. It still said plus 7. Now I can combine them. 2z's plus 6z's, that makes 8z's, and 7 plus 10, that makes 10. So I end up with 8z plus 10. And finally, question 9, we're going to simplify this expression, 2 plus 3 times the quantity, 9 plus x, by both using the distributive property and combining like terms. So I need to use the distributive property here because this 3 is multiplied by this group. You might be tempted to add 2 and 3 first, but in GEMDAS, multiplication comes before addition. So we need to use the distributive property. We need to multiply 3 by both of these before we add the 2. The 2 gets left alone for now. 3 times 9 is 27. 3 times x is 3x. Now I can go ahead and combine like terms, and look at that, they're already next to each other, 2 and 27. They're both constants. 2 plus 27 is 29, so I end up with 29 plus 3x.